So we have the inflationary multiverse. We have a different math here. So now let's switch to the cosmological multiverse. This uses exponential numbers instead of probabilities. So during inflation, a quantum field fluctuates. Let's say the field has a value of 10 to the 12 in arbitrary units. So in quantum field theory, the amplitude of a random fluctuation is roughly h over where 2 pi here, where the capital letter H here is the Hubble constant during inflations. So if H here is approximately equal to 10 to the 14, a typical number, then the quantum fluctuation is equal to this 1.6 times 10 to the 13. So this tiny fluctuation gets stretched by inflation. So if inflation expands space by a factor of e to the 60, about 10 to the 26 times, that tiny quantum space becomes a macroscopic region of a space with slightly different physical properties. Now, here is the numerical multiverse predictions. So the math says that in an eternally uh, inflating universe, the rate of creating this bubble region is constant. So if your inflation lasts for an infinite amount of time, which the equation allow, it creates an infinite number of these bubbles. So the probability of any specific combination of quantum constant is 1 over infinity. But because there are infinite bubbles, every possible combination occurs at an infinite number of times. So in this mathematical framework, our universe with its fine-tuned quantum constant is just one of the infinite possible outcomes. So if you write down the quantum wave function of the universe and solve it numerically for a simple system, so before measurement, you have one wave function with the equal amplitudes 0.707 and 0.707. So after interaction, you have two distinct branches, each has still carrying an amplitude of 0.707. So after the coherence here, the interference terms the of diagonal numbers in the matrix go from 0.5 to 0, meaning the branches are permanently split. So the math does not say one branch disappears. It says both branches persist with their original amplitudes. So if you ask a question, give me a numerical proof of the multiverse, they will hand you the density matrix with a zero in the off diagonal and say the math says both branches are still there. The zeros prove they are mathematically real, even if they can't see them. So if they will also add math is not a physics. So the numbers predict it, but we need an experiment to prove the other branches actually exist.